Hey there everyone, all the techies and data enthusiasts there. This is video 7 of our Django Generative AI series, and in this particular video we are going to discuss about large language models, which are nothing but LLMs. So in today's video we will discuss what are LLMs and their evaluation from those pre-trained NLP models to the present large language models which you are seeing, whether it can be OpenAI ChatGPT or Meta's Llama 3.8b or Mixtral model, all these models evaluation, and then we will discuss about the difference between pre-trained models and fine-tuned models. Then finally we will wrap up the video. So guys, this video is definitely gonna be a very interesting video. Make sure to subscribe the channel, on the bell notification. Soon we will be doing our project, production level end-to-end Django Generative AI project. So if you are interested with that, do watch this video completely, because to do that particular project we should definitely understand what are LLMs and how they play an important role in a RAG system. So guys, now let's get started. Importance of large language models. So large language models are actually a groundbreaking advancement in artificial intelligence or AI, which has revolutionized how we engage with technologies. These models can understand the commands what we are trying to ask it, and generate text and even translate the language, and even they can help you write code by leveraging the advanced machine learning and vast textual data. So here what we are normally trying to tell is large language models are a kind of LLM models which is similar to our human brain. Even it has a neural networks connected internally, where the model has capability to store the information, like store the information, in a sense process the information mainly, and ultimately these information will be stored in them itself. If it's a LLM, not a RAG. In RAG it is different, but when it comes to large language models, the model is already trained on vast amount of data. If you have heard this Llama 3.8b, what is this 8b? 8b is nothing but the 8 billion tokens or 8 billion parameters. The model has trained on 8 billion parameters, so that is why we call it Llama 3.2b model. The same way, if you see even Mixtral you have, and even Llama 4.405b, which is 405 billion model parameters this particular model is trained on. So that is what we normally call it. So it is similar to our human brain. So this particular LLM models can generate text, understand the commands what we are giving to it, and even if there is any error in your code also they can solve it. That is one of the main advantage of LLM models. So how these LLM models came into existence, which is powered by transformers, a neural network, which is nothing but transformers was the first architecture which was released on 2019 by Google, because of which the AI and LLM space has been revolutionized. Now what all LLM models you are seeing, Mixtral based models or Llama or even OpenAI ChatGPT, all these models are actually created or using this same architecture of transformers. Without transformers, we wouldn't have come in this long in the AI space. Okay, so that's what we normally, this is the importance of normally a large language model. So the characteristics of large language model. Large language models are sophisticated AI systems that leverage deep learning techniques to process and generate natural languages. So here these particular models has the capability to process the information and even the generate response in a natural language how we humans can understand. So they are characterized by scale, architecture and versatility. Scale: LLMs are trained on massive amount of data, often accomplishing billions of words from books, articles and websites. This extensive training enables them to learn, create or intercreate the patterns in between them. Okay, it's actually intercreate between patterns between those particular languages. So I am not able to spell it properly. Architecture: most LLMs are based on transformers model. So I told you, right, transformers architecture. So if you want to refer transformers architecture, so go to a new tab and just type attention is all you need. So you might have got the doubt, what is this? You told transformers architecture and again you're telling attention is all you need. So actually, attention is all you need is a research paper which Google has released. So you can see here from Ashish Swasavani from Google. So this particular person is the main, or you can see the main mind behind this main person who played a key role in releasing this transformers architecture. So if you, this is actually called as the transformers architecture. You can see a model architecture, you can see, right? So here you can see the transformers, a model architecture. This is actually the transformers architecture. So I have created a detailed playlist explaining this transformers architecture. What are the input embeddings and what is attention mechanism and positional encoding, feed forward neural network, why this is used. This is actually an encoder and this is a decoder model. What is the difference between encoder and decoder? All this I have explained clearly in that particular playlist. The playlist link is in this video description. Check out, make sure to watch completely and understand about transformers as well. So attention is all you need is the paper name, and transformers is the architecture. Transformers is the model name and it's an architecture. If you search for transformer also, you'll get this architecture. Okay, let's get back. Versatility. These models can perform multiple functions such as text generation, summarization, translation, and even code assisting. So these models are capable of doing all these tasks. Even now they are even voice to voice based communication. If you go to ChatGPT and just select the voice option, whether even it can be Gemini as well. If you talk to the model will talk back to you. So it is even a voice to voice communication as well. So the AI and LLM model space is evolving day by day. So you can see here, these are some of the characteristics. Now key features of LLM. Text generation. The model has the capability to generate text based on prompt. And language translation. They can even translate language from one language to another language accurately. So after ChatGPT only you all know about what is AI, what are LLMs and how it came into existence and everything. You all know even before ChatGPT, actually the AI came into existence on 2015 itself. I was actually studying my, I guess, yeah, my college inter first year. So okay, so at that time only AI came into existence, but what everyone know as an AI at that time is chatbots, or it can be robots, rule based robots, command based robots, and even you can say these models which you are seeing your language translation, which is nothing but Google Translator, which came into existence. How Google Translator is able to translate the languages, that is using this only. Okay. So before you can say before ChatGPT came into existence on 2019. Yeah, most probably 2019 November according to me. So before that, most of the people what they know about AI is building rule-based engines, rule-based chatbots where you ask a set of question, precise question, based on the question the model will respond you. It doesn't have the capability to think, it is rule-based. And number two is robots. So they were trying to build the robots on commands based. So and after apart from this, and what else is left out? So language translation, Google voice assistants and everything. Okay. So after ChatGPT, even people then got to know, okay, even the LLM model has the capability to think. It can think like us. It can even talk to us. Even it has the capability to analyze what we are telling. Based on that only, now if you give any error, the model will understand the errors and it will answer you because it is trained on that. Then you have real world application. LLMs have found applications across various industries like customer support, content creation, and programming assistance. So in customer support, you can use chatbots that is powered by LLM. Whatever question you ask, it will answer you back. Content creation tools like GPT-3 and even Mistral and Llama 3.8b and Gemma models. Google का Gemma ने क्या किया है? So Gemma models, why we have to leave it back? So Google Gemma models are there. Even they can answer you. Okay. And programming assistants which can be GitHub Copilot and Tab9 was there. There were multiple coding assistant models which has the capability. Even now you have the capability. Here also if you click on code and if you just click on generate here and if you type here any question about like give me hello world program. So Gemini is internally connected here. You can see here hello world program is here. Okay. So the model is connected here internally with the Gemini LLM model and it has the capability to give you, it is your co-pilot when you are writing code. If you have any errors, you can ask it. Okay. Then LLM architecture. LLM models, large language models have revolutionized the field of natural language processing through various architectures, each designed to tackle different aspects of language understanding and generation. Among them, the most popular LLM architectures are GPT, which are nothing but generative pre-trained transformers, and BERT, bidirectional encoder representation from transformers, and T5, text-to-text transformer model. So these are some of the advanced models which you need to understand. GPT only has the capability to generate. So encoder decoder model I have told you, right, in transformers, GPT can only, it is only built upon decoder, stacked version of decoders. So you get it as generator. So whatever question you give, it will generate the answer. But is stack representation of encoder. Here the model can understand what you are trying to talk to it. And T5 is combination of the transformers architecture, which is both encoder and decoder. So T5 will come when you combine both encoder and decoder. So these three are some of the important models. If you are learning NLP, you should definitely know them, including AI. So make sure to learn about them. Here I'll give you an high level overview, but go in detail and try out to do a project on it. You will learn a lot. Okay. GPT is a model developed by OpenAI that focus on generating human-like text based on a given prompt. It utilizes only a decoder architecture, which means that it is primarily designed for text generation tasks. So here you can see the architecture, transformers architecture, it has used attention is all you need paper. So from 2017, it actually came into existence on 2019. It employs a stack of decoder layers. 2019, no, 2019 ChatGPT came into existence. 2017, yes, correct. Layers and self-attention mechanism to process input text. Unidirectional processing. Unlike BERT and GPTs, GPT process text in a left to right manner, which is predicting the next word based on all the previous words. So here what BERT has the capability normally is, BERT can predict the missing word, like fill in the blanks in where the missing word it can predict. But GPT can directly generate the answer based on the question. So you can say like BERT is good for MCQs and fill in the blanks. GPT is good for 5 marks question answering or 2 marks answering. Okay. So parameters. The model size varies across various versions. So GPT-3 is 175 billion parameters model, making it one of the largest model in till date. So actually this is wrong information. Now Llama's 4.5b model is the largest version model. Okay, so it has 405 billion parameters. Llama 3.54b model, 405b model. Key features: autoregressive generation. Generate text by predicting the next token in the sequence using the prior information or prior tokens. Fine tuning. After fine tuning on diverse datasets, GPT can be fine tuned to specific tasks such as summarization, question answering as well. Applications: GPTs are been widely used across applications like ChatGPT or chatbots and content creation, programming assistance, demonstration, and more. BERT, bidirectional encoder representation from transformers, which is BERT, developed by Google AI language, focusing on understanding the context of words in a sentence rather than generating the text. This employs the bidirectional encoder architecture only. So here the main difference between generator model, which is nothing but GPT, and BERT is BERT can understand the context what we are trying to give it, but GPT doesn't care about it. It directly generates the answer. Now GPT-4 and these all are different case. Here the model will try to understand what you are trying to tell, but when it's completely different right now what you are seeing. Previously it was like this. Bidirectional, okay, key features: bidirectional contextualization, so it can analyze both the side, like what we are asking the question, it can analyze the context and what it is giving, that also. Model variant: BERT comes with base variant which is 110 parameters, and BERT's largest is 340 million parameters model is the BERT large. Okay, allowing the users to choose the model according to the computational resource and the task requirement. Application: BERT excels on various tasks including sentiment analysis, NER, name entity recognition, and question answering. It is able to understand the context, has made it to go to model for many applications. When it comes to T5, so T5 is combination of both. So here it has both the capability of BERT and GPT. So unified framework, T5 uses both encoder and decoder components of transformer architecture and pre-trained on diverse tasks. T5 was trained on a large dataset called C4, Colossal Clean Crawled Corpus, which includes various types of textual data to enhance its versatility. Key features: text-to-text paradigm. By framing all tasks as converting input to output text, T5 simplifies the process of adapting the model for different NLP tasks. Flexible prompting. Users can specify tasks through prompts like translating English to French or summarizing the article, making T5 high adaptable to various applications. Okay, pre-trained models. So what are pre-trained models and continuous pre-training? What is continuous pre-training and what is fine-tuning? We will understand this. These are related to LLMs. Okay, so previously whatever I explained you, those are the models which are before ChatGPT. Now what I am going to explain you, that is models which you require right now for LLMs to understand, pre-trained models. Pre-trained models are neural networks that has already gone the initial training on large data sets to learn general features and representation of data, and this can be typically done through unsupervised learning technique. So what is pre-trained models? These are the models which are already trained on large amount of data, which can understand what we are trying to ask it and which can understand the maximum information what we try to ask it. So it can only understand, but it is a pre-trained model. Whatever information it has, based on that it can answer. It cannot answer the unseen information. Key characteristics: so generates knowledge base, general knowledge base, efficiency in transfer learning, advantages: fast deployment and versatility across tasks. These are mainly the key characteristics and advantages. But when it comes to this, right, let me give you a good example for pre-training. You can take a model like Llama model only, Llama 3.28B model, I guess. Yeah, those models, if you go now and ask who is president of US, that model will tell you Joe Biden, because when the model was getting trained, the data which was given to it was when Joe Biden president. Now if you ask it, it will not be able to answer because the model doesn't connect to the world. So it is called pre-trained models. When it comes to continuous pre-training, continuous pre-training refers to the process of taking a already pre-trained model and further training it on additional domain-specific data. This approaches enhance the model understanding for specialized terminology and contexts, retaining its general knowledge. Okay, so here key characteristics: utilization of unlabeled data can be done, transfer learning application, and domain specific adaptation is the main advantage here, and improved performance. So now continuous pre-training model, you can even take example of chat GPT as well. Continuous pre-training is nothing but reinforcement learning. When the model gets something new information which it doesn't have, the model learns from it. So reinforcement learning, which is nothing but continuous pre-training, and you can take example of chat GPT. Whatever you are asking question to it, whatever is on Google, Google is connected to it. So this particular model, what it does, chat GPT 4 or any model, even perplexity model, so they are continuously training themselves, including Gemini. They are connected to Google. Whatever latest information is on Google, they will train on them. And we are talking to the model, whatever informations we give it, if it feel it doesn't know, it will start to take those model, and it is continuously pre-training itself. It is adapting themselves. Fine tuning. So pre-trained models and continuous pre-training, you have understood, right? Fine tuning is nothing but the process of taking a pre-trained model and adapting it to a specific task using labeled data. So this step just adjusts the model parameters. Here what we are going to do, nothing but, so before let me tell you the key characteristics. Task specific data. The model is only trained on task specific. Optimization for specific tasks is done here. So if you, whatever task you want to give to model, you can just give that data set. For example, you want the model only to be a Geo customer care representative. So how the Geo customer care representative talks to the users, so you can take the data and fine tune the LLM model with that. So the model will start to learn based on the new data, and it will only adapt to that. In such a way, what it happens, the model will only answer your question based on the information it has. So when you are fine tuning it, you are giving a new information, so it will answer you based on this updated information. Advantages: enhanced accuracy, resource efficiency. So here when it comes to before fine tuning, how it used to happen, so Geo customer care representative, then the model, you should build a model from scratch. You have to train completely a big model, you have to build it, and finally you will get a model which is nothing but pre-trained Geo customer care representative. So it's a time taking process and more resource intensive. So to overcome this, what researchers have done, they have come out with something called fine tuning. So here what we do, you have a model already, take any model, I don't care, take the model which is perfect for your task. Then I will give you the latest data which I have, and just fine tune it, means train it with this latest data, tell the model to understand this data and answer only questions based on this data. Over. So if you do this, it is less resource intensive, resource efficiency is there, and it doesn't take much time as well. Okay, and finally here you have comparison, what are pre-trained and fine-tuned models. So pre-trained model, general language models. Fine-tuned models are nothing but they are task specific adaptation. We can adapt the model to task specific. Training data, trained on diverse data sets. Fine-tuned models, small and targeted data sets. Performance, good and general performance, enhanced performance on specific tasks. Training cost, high initial cost due to extensive data, low cost because you build upon pre-trained knowledge. Flexibility, versatile across various applications, optimized for specific use cases is fine tuning. Uh, Layer training, all layers are generally trained, but in you can say fine tuning, selective layers are layer trainings of trained and some are freezed. In summary, pre-trained models provide a robust foundation for various machine learning tasks for capturing general features. Okay. So here right now fine tuning is in edge. What all the researchers are doing right now and building the latest models which they are using for their specific task. All those LLM models are fine tuned actually. Pre-trained models are your default models which are available from the company, which it can be from Meta or it can be OpenAI. But fine tuning is you are telling the model to work on a specific task only. Okay, I hope you all understood this. So guys, in our next video we are going to discuss about RAG, what is RAG and its key features and why we need large language models there, and finally we are going to discuss about vector database as well. So for our project we require a vector database called Quadrant. There we will discuss about it and how can we set it up. So guys, that's all for today's video. Do like, share and subscribe the channel. Meet you all again in my next video.